Hello all, welcome back to the EduMoon tutorials. In this video, the continuation of the last topic, we'll see about the simplification of the CFG. So here when a grammar is given which is in the CFG, we try to minimize the number of production rules based on some rules. So the first one here is, first we try to remove the useless symbols. So how you define a useless symbol is, if a symbol is not derived from the starting symbol S, we call it as a useless symbol. And also if a symbol doesn't derive any terminal, that is also called as a useless symbol. So for example here, removal of useless symbol indicates, so let us take an example of a grammar. S equal to B and B is equal to A and C is equal to B. So assume that this is a given grammar where it has some set of productions like this one. Now you can see S is deriving A and B. So when you draw a grammar like this one, S can be deriving A or S can be deriving capital B. This is capital A. So the production rule or else the variable should be reachable from the starting symbol S. In this grammar you can see that the variable C just cannot be reached from the starting symbol S. So when you draw the derivation tree or the parse tree, the variable C cannot be reached from the starting symbol S. So we conclude that C is a useless symbol. And also here in the production rules given, the symbol A, the variable A is not been derived any terminals. It's not been given in the next derivation. So we conclude that A is also an useless symbol. So in this grammar only we can conclude that therefore only S and B are the useful symbols, the remaining are useless symbols. So we can simply eliminate symbol A and also symbol C. So let us take one more example like S tends to AB or CA and B tends to PC or AB, and next production of C is given as AB or B. Production of A is given as small a. So let us assume this is the given grammar. So first of all we check which are the useful symbols here. So S is a starting symbol, that is a useful symbol. Next A, you can see that the symbol A is being generated from the starting symbol S. So when you draw the tree like S, you can reach the states A and B, and also S can be derived as C and A. So you can see that S is been deriving both the symbols A, B and also C. So all these are useful symbols as of now. And now you can see the derivation part. B is generating again B and C. So B is generating B and also C. And at somewhere in the tree, on the derivation tree, the C can generate a symbol called terminal B. So it is a terminal B. So it can stop the process. But you can see B can again further generate A, B, and also again B can generate B and C, and so on. This is going into a loop. So this is actually recursion, what we have discussed in the earlier class. So this is a recursion where B cannot be stopped by substituting any symbol because B is not generating any terminal. So we conclude that B is an useless symbol here. So B is an useless symbol because it is not deriving a terminal. It is of course reachable by the starting symbol S, but it's not derived from the, it's not deriving any terminal, so it is useless. And now C is generating a symbol called B, that is a terminal, and A is generating a symbol called A, which is a terminal. So both these are useful symbols. So in this grammar, S, A and C are the useful symbols. So you can simply eliminate all the productionals that include the capital B. So the second step in the process is removing the epsilon productions, so which are also called as null productions. So we remove the null production, the simplification process. So any productional that has a production of type this one is called a null production, or else a production with epsilon moves. So we remove these productions to simplify the grammar. So let us assume a grammar here. So when we take this grammar as an example here, so X is actually producing AS, and if we substitute A equal to epsilon and B equal to epsilon in the given grammar here. So that produces the null again for S. So again this includes A and epsilon, which can be written as simply S equal to A. And when I produce epsilon for here only A, you get a single B. So the S productions will be like S tends to AS. And if you substitute epsilon for B, you can remain only A. And if you substitute epsilon for B, it is A. And if you substitute epsilon for A, it will be B. If you substitute for both of them, it will be A and finally AB. So simply these are the production rules that are generated after eliminating these two productions from the grammar which are having epsilon production rules. So this is how we eliminate the epsilon production just by substituting that epsilon wherever this variable which is generating an epsilon is present, just substitute epsilon there, and whatever the new production rules we get, we include them in the grammar. So this is how we eliminate the epsilon productions. So the next point, what we do in this simplification of grammar is the third one. Just remove the unit productions. Unit production we call it as. So a production rule which is in terms of A tends to B. So this is called as unit production. That is, a variable is generating another variable, only a single variable without any terminals or more number of variables. So what is the disadvantage here is, for example, in the tree after getting A, again A is generating only B. So this is actually increasing the levels in the grammar, nothing more than that. For example, if the A is generating some variable like this, you might get two symbols, but the unit production will generate only one symbol. So instead of this one, directly A, we had only B there, right? So this is actually again we can have the B production there, something assume like AC again. So this is actually generating two symbols. So instead of, if this is not there, and this is called as a unit production here, which is actually increasing the level of the tree. So instead of directly writing A, we can just simply write A to B and B to A. So we can simply write it as this one, so that this level will be eliminated and the tree can be just this one, the capital A, and A is generating again A and C. So just eliminate this one, just the level of the tree. So we can eliminate the epsilon productions or unit productions here. So once the grammar is given for simplification, we follow these three methods, these three steps in the process of simplifying the grammar. So first of all, we'll identify the useless symbols and eliminate the production rules which are containing those useless symbols. Next, we eliminate the epsilon productions, and then finally the unit productions. If they are in unit productions, we just eliminate them in the given grammar. So this is how the simplification of the CFG will be continued. So taking any other example, we can do that. Like for example, this is a given grammar. So actually here taking a random grammar here. So in this grammar, if you try to observe the grammar rules, let's write one more production here. So you can see what are the useless symbols here. First of all, we take from S. S is the starting symbol. So first of all, you try to eliminate the useless productions, useless symbols, and S is deriving A and B, so they are reachable from S, and also C and D. So of course they are reachable. And the production E. So when you draw the derivation tree here, so it might generate C and D, and actually D is deriving E. So we can consider that E is reachable from the starting symbol S. And next we see what are the variables that are not generating any uh, terminal here. So here you can see the production B, the B production which is not generating any terminal, because the tree you can see B is generating this one, small b and capital B here. Again this B will generate a small b and capital B, a terminal and variable, and so on. This B can never be stopped. So we consider that one as an useless symbol. So here this is an useless symbol. And you can also eliminate any epsilon productions. So there are no epsilon production in this given grammar. So finally we try to eliminate the unit production. So we had one unit production here, E. So simply you can eliminate that E. You can directly substitute the value here, D equal to this one. So which is already present for D equal to A. So you can simply eliminate the E productions also, because it is a unit production. So the final productions and the grammar are containing only the values, so whichever I am underlining there. So these are the values that are available. So here we eliminated B. So since B is eliminated, again this production will be eliminated here, and so A will also be eliminated, because since this is eliminated here, only this production will be left out. So here this production is also eliminated, because once you eliminate this production rule, S will be generating only C and D, and it cannot generate this A anymore. And of course B is eliminated. So finally the productions that are left out are C and D. So this is how the simplification of the CFG is done. In the next video we'll be seeing about the normal forms, which are CNF and GNF. So that next video will be uploaded with the normal forms called as Chomsky normal form and the Greibach normal form. Thank you.